Hello everybody and welcome to another tutorial. This tutorial is going to be a little bit different. We have this nice effect that can burn any mesh. So this is the monkey from, Blender, and using this ball you can make it burn, right? And this effect consists of two things. One is a visual VFX graph, which creates the fire. The other part is shader graph shader, which is applied to the monkey so that it cuts open the monkey based on this ball, right? And it works with any mesh. It also adds a noise texture to the distance, and it also works on animated stuff, as you can see here. There are things that you can tweak also. So if we click on this graph, you will see you can change the random velocity on the X and Z, which will spread the fire. You can increase the velocity on the Y, which would make it fly faster. Size over life, which can make it smaller or larger. We also need to supply a texture of the noise that we want to use, and we have the noise power and size. Currently they are changed from this script so that it changes this value both in the visual effect as well as in the shader at the same time, just for the sake of simplicity, but you don't need to do this. So you can see this changes the size of the noise, and this changes the power of the noise. You can change the spawn rate, the distance threshold, which is basically how much of the edge should emit fire. So if we increase this a little bit more, you will see more of the edge is increasing fire, and so on. This is the mesh, the same mesh that is being rendered here, which is the Suzanne monkey. And this is the flipbook, which is a texture of an animated, like smoke. And then you have to supply the dimension of this flipbook. It's 5 by 5. And then the ball position, which is the position of this ball that's affecting the effect. It's also being supplied by this script. This script basically checks where is this ball and sends the position of this ball to the effect, as well as the size of this ball. So if you are to scale this up, scale it down, it works that way too. Now for the shader, you can change things like the threshold, which is how much glow you want to see. You can change how smooth the transition is. Of course, you can change the multiplier of the color of that edge, as well as the color of the edge. And again, same noise power and noise size, so that it matches the effect. And these two are set from that other script that we talked about. The only issue about this effect is that the emission of the particles is equal for each triangle of the mesh, which means if the triangle is small, it's gonna emit, say, 3 per second, 3 particles per second. If it is large, it's also gonna be 3 per second, which means the places of the mesh that has smaller triangles are gonna have much more particles, as you can see here, rather than the bigger place, right? Yeah, but that's about it. And now we can jump to the actual implementation. And we are going to start by looking at the shader graph. You can dock this back here. And this here. Going to shader graph. So we are going to get the noise value, and the noise value is going to be 2 samples of the same 2D texture, so that I don't need to create a 3D texture and all of that stuff. So I sample the 2D texture of the noise, and it has to be seamless 2 times. Each time based on basically first time based on X and Y, which is if you connect the position of the vertices in world space. Of course, after you multiply it by the size, the noise size parameter, this is gonna take the X and Y and sample it based on X and Y. And here we are getting the Y and Z and sampling based on Y and Z, right? And this is gonna look something like the noise texture. And if we go to noise, it's going to look like this, right? And like this. And so we add these 2 values together, which is gonna make our values between 0 and 2. We subtract 1, so that the value is between 0 and 1. Between -1 and 1. And then we multiply by the noise power. And then we have our, and again, this noise power has to be, you have to have this name because I'm referencing that in that C# script. Unless if you don't want to use that the same method of setting this from the script, you don't need to actually care about this. But this name is how you set the parameter values from a script. So it's going to be the noise power, the noise size, as well as these 2, the ball position, ball size, which we are going to look at right now. So now after this we have our noise value, and here we need to find the distance between each vertex and the position of the ball, right, using the distance function. And then we can add the value of the noise to this distance. After that we subtract the size of the ball, which is gonna give us a value basically on the edge is gonna be 0. The place that needs to be hidden is gonna be in the minus, and the place visible is gonna be in the positive, which means we can use that in a clip function. So this is a custom function node, which takes an input of a float, an output of a float, and you can name it whatever you want. And all I'm doing is calling this function clip, which basically does not render that pixel if the value given is less than 0, right? And I'm just setting out to 1. I'm doing this kind of like a hack because the clip function just needs to be called. We don't care. We don't need anything else. However, if you don't connect this function to something that goes into the output, the compilation is just gonna ignore it completely. At least that's what I experienced. So I'm just setting out to 1 always, and then multiplying it by the value I'm using, so that it's part of the whole thing, right? So this is going to hide our hidden section of the mesh. And then here, after that, I'm adding the threshold parameter and putting that into the in of the smooth step. The first edge is going to be 0. As I mentioned, 0 is the edge of that effect. And I'm going to put in the smoothing parameter into the second edge. And then, as I mentioned, I'm just multiplying it by 1, this thing. And then that's our value for detecting the edge connected to the T of a lerp. And then in my case, I don't want any emission on the mesh except on the edge, right? And so this is going to be our color multiplied by a value so that it's glowing when you increase this value, right? Because of this color parameter does not allow HDR values. And that's our emission. Of course, you can do whatever you want in the other ones. You can add whatever texture and normal map and all that stuff based on your usage. So this is it for the shader. Going to the graph of the VFX. Save. Okay. Here we have a parameter for the spawn rate, just connected like that. You might wanna make the space world if you wanna move your object and the flames stay in their place rather than moving with the object. That's up to you. You can try that. And capacity, I put it to 10,000. You can try other numbers if you want. We have a mesh parameter, which is connected to this position mesh, and the placement mode is surface, and spawn mode is random, right? Which is gonna randomly set the particle position randomly to some surface of that mesh in a random position on that surface. After that, I'm just connecting the lifetime parameter into set lifetime random, which is X is gonna be our minimum and Y is gonna be our maximum. This is basically a vector 2. After that, to kill, so until this step, it's going to emit particles all over the faces of the mesh. And then I'm setting the lifetime of all the particles except for the ones on the edge to basically 0, right? I'm multiplying it by 0. And I'm just going to show you now the calculation for that, which looks very similar to what we have in the shader graph. Here, except for, to get the position in the shader graph, it was getting the vertex position in world space. Here, you are going to get the position of the particle after it's been set to be random from that mesh. We get the position of the particle and we put it in this transform, and it's going to be from local to world, right? And then we are going to create our noise the same way. We get X and Y, and we get also this is basically X and Y from here connected, and this one is Y and Z, or the other way around, doesn't really matter. And then we multiply. I could have probably multiplied this value first, but anyways, we multiply these by the noise size, and then we connect it to a sample texture 2D. This has to be again the same texture as the one we assigned to the shader graph. Sample 2, add both of them, subtract 1 so that the value is between -1 and 1, and then multiply it by the noise power, and that's our noise value, right? And here we get the distance between the particle and the ball position, right? Again, these guys, the control, I guess it's in the inspect. Yeah, so this has to be case sensitive, obviously, with our script if you want to set it from the script. So ball position, we get the distance between the ball position and the particles, and then we add it to the noise value. And then after that, this is where it's a little bit different from the graph. We are subtracting the ball size from this value, and we are getting the absolute of that. So this means on the edge it's 0, and then it goes into the plus on this side and on the other side, right? And which means that we can use that in a step node, and we give it the threshold, and that's gonna basically make whatever is 0 or a little bit more than 0 to give us 1. Otherwise it's 0, right? And so when we multiply the lifetime by 1, it stays the same. When we multiply it by 0, it basically kills that particle. And after that, I'm setting some random angular velocity on the Z, which basically rotates the particle like this or the other way around. This is optional, obviously. I'm setting a random velocity on the X and Z. This is basically multiplying by -1, which is to give it to the minimum, and the value directly to give it to the maximum. And this is the Y velocity. I'm just putting it without random. You can do the same for this one as well. It's up to you. Update particles doesn't have anything. And output is a particle quad, which is the default, I think. And you have to, if you want to use a flipbook like how I did, you have to use the flipbook. You can choose either flipbook or flipbook blend, or this one. This is probably not very suitable anyways. And the layout is texture 2D, and I'm using alpha. You can try with additive or other ones, but that's what I like the most. The flipbook size is our parameter. It's a vector 2, and the actual flipbook is just a texture 2D. By default, it's gonna face the camera, and we are gonna set the color over life to our parameter, which is just a color parameter, and the size over life to the size curve, which is a curve parameter. And then set texture index is what changes the basically the animation of the flipbook, which square to use from that flipbook, right? And so there is actually a block that you can put in like the update particle, which plays the flipbook, but it doesn't allow you to place it based on lifetime. Basically, I want when the particle is once it is alive, I want to use the first square, and as it goes through its life, I want it to use everything until the end exactly, right? That block does not do that. It just changes the texture index based on just time. So to do that, I did some calculation, which is dividing the age of the particle over the maximum of the lifetime that we are passing, right? This is going to give us a value between 0 and 1 based on the lifetime of that particle. And there is also a get lifetime, but it didn't work for me. I don't know why. Anyways, I'm getting also the size of the flipbook, multiplying the X and by the Y, so that I have the number of squares in that flipbook, and then subtracting 1 so that it starts from 0, and then multiplying that by this value, which is going to give us basically which texture to use over the lifetime. Yeah, and so that what makes the animation of the flipbook and all the other stuff that I mentioned. My flipbook looks something like this, which I created using Blender, using the quick effects of creating smoke, basically. And the noise just looks like this, and so on. What else? The script that I mentioned, so here, which is set props, is gonna look something like this. It's gonna take our the ball, basically, right, the effect ball, and the material, and we have our noise power and noise size, and the visual effect component. I'm assuming that this script is going to be on the same object that has the visual effect component, so I get that reference in the start, and I assign the material manually. And so if both of them, I'm also assigning the ball manually. If the ball and the material are assigned, then we are going to basically set the position of the ball, right? And the ball size is going to be the X or Y or Z of the scale of that ball. Noise size is just going to be our parameter. Noise size and noise power is going to be that same thing. And then I'm doing exactly the same thing for the material. It's just that the name, the reference name of parameters in shaders has to cannot have a space, so it automatically puts an underscore in that. Setting the same properties to the same stuff so that it matches, and yeah, that's about it. The oh yeah, the other thing is I have this thing here which executes in edit mode, just so that this code actually works always. Basically in edit mode I don't need to go into play mode, but it's up to you whether you want to do that for testing or whatever it is, right? Yeah, that's gonna be it for this tutorial. Thank you so much for watching, and make sure to click the links that are in the description. It's the only way I get support from you guys, and see you in the next one.